Hey guys! So a lot of you have been asking me why I'm not in my videos and why it's only my sleep. So here I am. So what are we talking about today? Dynamic programming. Well, first of all, welcome to my interview prep series. Well, what is dynamic programming? Dynamic programming is a programming approach that optimizes more complex problems. Well, how does it do that? So it'll do it through resolving simpler subsets. So, dynamic programming is applied to a particular set of problems. These problems have two specific characteristics. One is problems with overlapping subproblems. The second one is problems with optimal substructures. So why is dynamic programming helpful? The reason is that dynamic programming will drastically reduce the time complexity. So there are two main techniques for dynamic programming. One is called memoization. And the second one is tabulation. In this video, we're going to be focusing on memoization. So, memoization is a, first of all, top-down approach. It can be implemented using recursion. It only needs an added cache. We have a cache that stores the previously computed results. So there are two ways to implement memoization. First is the helper method of recursion. In this case, a cache can be created using a hash table. This hash table is going to be stored as a scope variable. Prior to calling a subproblem, we can check the cache to see if the result has already been computed. The second method that memoization can be implemented through is using function decorator. So this function decorator is going to be separate. It will allow the function to have an outer scope. This contains the cache and the logic to check for previously computed subproblems. Well, now let's solve a quick example together. This example is solving the Fibonacci problem, this time using memoization. In this example, we'll just see how to use a cache and a helper method for solving minimization. Alright, so we can go over the components of this example. The first thing that we do is we create the cache variable. In this example, we're using JavaScript, so the cache is going to be stored inside an object. The next thing is creating the helper function. So the helper function takes in an input variable. The helper function is then invoked outside, and its input variable is going to be n. So what happens inside the helper function? This logic checks if the subproblem had already been computed and stored inside the cache. So we say if the cache already has the value computed for the current subproblem, then we just return the value. We also say if current is less than 2, then we just want to return current. Finally, if the computed value is not stored inside of the cache, we want to calculate it. We do that by calling the helper function twice, once for current minus 1 and once for current minus 2. Finally, we return the cache and we store the current value inside of the cache. So what is important here? The first thing is that we realize that we have a shared subproblem. The next thing to understand is that we're identifying each subproblem with n, and then we're mapping each subproblem to helper n using the cache. The benefit of this example is that it's going to save a lot of time, and it's going to reduce the time complexity, and that is because we're not resolving our overlapping problems. So that concludes the example for today. A lot more examples on dynamic programming, and I hope that you guys are learning a lot from my interview series. Let me know if you have any questions and subscribe to my channel for more videos. Have fun and happy coding!